Hi everyone. Today we will discuss about the heat transfer. In that, how many next problems is there based upon that derivation only. Fourier law of heat conduction, Fourier law. So somewhat like this question will be given. The question will be given here. A plane wall is 150 mm thick. A plane wall is there. So first, what you have to do, you have to draw the plane wall. This one you have to consider as the plane wall from here to here. This one you have to consider as the plane wall. This one is your plane wall. How much thickness is there? From here to here, thickness is already given. How much it is given? 150 mm. How much thickness is given? 150 mm. This one you consider as a plane wall. Okay, now I will write here plane. This one is the wall, plane wall. This one is the plane wall. How much thickness is given? 150 mm thickness is given. So whenever I told you thickness is given in mm, first try to convert into meter. Try to convert into meter. So what you have to do? TL or TX is equal to 150 mm is there. 150 mm divided by how much? 1000. 150 mm divided by how much? 1000. It will become like this. 0.015 meter, 0.15 meter. So it will become 0.15 meter. It will become 0.15 meter. So whenever thickness or length is given, first try to convert into meter. I told you in the last session, if something is given in mm, what you have to do? Divided with 100. The answer should be in meter. If something is given in mm, what you have to do? Divided with 1000. The answer should be in meter. You have to remember, if something is given in mm divided with 1000, the answer should be in meter. If something is given in centimeter divided with 100, the answer should be get in meter. So whenever thickness is given, first try to convert into meter. There only you have to convert that. Then suppose in by mistake if you substitute the same value, then you will get the different answer. So better to convert that. After conversion, what you have to do? Next step, after conversion is over. So we will go back to our question. What is question is given? A plane wall is 150 mm thick. That is your plane wall. How much thickness is there? 150 mm. Okay, no? That is your plane wall. How much thickness is there? 150 mm. And its wall area is 4.5. First time area is given. Okay, now in this problem, what is given? Area is given. So right here, area. I will write here area. Area is equal to how much? 4.5 meter square. Area is equal to how much? 4.5 meter square. In this, area is given. So area unit length into breadth, mm meter into meter. Meter into meter will be meter square. Meter into meter will be meter square. So area is equal to 4.5 meter square. After that, if thermal conductivity or thermal conductivity for this wall, conductivity. So here K value is given. How much K value is given? As you can see, 9.35 watt per meter centigrade. By seeing unit also you can identify 9.35 watt per meter centigrade. 9.35 watt per meter centigrade. That is your thermal conductivity of that one wall. Okay. After that, what is given? And the surface temperature are steady at two temperatures are given, 150 degree and 45 degree. What is given? First one, 150 degree surface temperature. So T1 you can consider as, first I will write DL. DL is equal to how much? 0.15 meter. And K value is equal to how much it is given in question? 9.35 watt per meter centigrade. After that, here two temperatures are given. First temperature you have to consider, higher temperature you have to consider as the T1. How much it is? 150 degree. And T2 is equal to how much it is? 45 degree. T1 is equal to how much it is? 150 degree. And T2 is equal to how much it is? 45 degree. You got the value of T1 as well as T2. Now he is asking to find out. Once again I will read the question. A plane wall is 150 mm thick. That one is your plane wall. How much it is there? 150 mm thick. So it is given in mm divided with 1000. The answer you should get in meter. And its wall area is given. Area is equal to how much? 4.5 meter square. And conductivity is given. Conductivity is equal to how much? 9.35 watt per meter centigrade is given. So watt per meter centigrade, by seeing that you can identify the given unit, how thermal conductivity. For that term it belongs to the thermal conductivity. After that, and the surface temperature are steady at 150 degree and 45 degree. Here two temperatures are given. First one is the 150 degree, second one is the 45 degree. Determine first what you have to determine, heat flow across the plane wall. Heat flow, you have what you have to find out, heat flow you have to find out. Second one, temperature gradient in the flow direction. Temperature gradient means difference in temperature you have to find out. How to find out difference in temperature? Already two temperatures are given. By neglecting that two temperature, again with the help of this data you have to find out the temperature gradient. I will tell you how to find out, but in every problem what you have to do, like this diagram you have to draw, okay na, like this diagram you have to draw. As you can see here, area is given 4.5 meter square, dx or dl or thickness is given 0.15 meter, and K value is given 9.35 watt per meter centigrade, and T1 value is given as well as T2 value is given. What you have to do, first you have to write down that one, okay now. What you have to write here, like this you have to write, Q is directly proportional to A dt by dx. Q is directly proportional to A dt by dx. Q is directly proportional to A dt by dx. After that, what you have to do, you have to remove the proportional sign. So, what you have to do here, Q is equal to minus Ka dt by dx. Q is equal to minus Ka dt by dx. After that, what you have to do means, Q is directly proportional to A dt by dx. After that, what you have to do, you have to remove the proportional sign. If you remove the proportional sign, equal to minus Ka, A write down as it is, dt by this one you can write as the dx, okay. After that, what you have to do, see here, Q is equal to, let it be minus K as it is only, dt can be write as T2 minus T1 by dx dl, or normally you can write as a L. Normally you can write as a L, it's up to you. After that, see here, Q is equal to this minus, if you multiply this side it will become Ka, write down as a T. Here you can write T1 minus T2. T1 is negative, here it will become positive, and T2 is positive, here it become negative, by L write down as it is. Then Q by A is equal to, A you have to send this side, but area it is given, so no need to send here, let it be fine. Suppose area is not given, so you have to find out the small q. In every question it will be not mentioned. You have to remember that whenever area is not given, try to find out the small q. But in this question area is given, so let it be area there only. After that, what you have to do, Q is equal to, here you can write T1 minus T2 by L by K by A. What you have to write, L by K by A, you have to bring this side. So, here you got the Q, here you got the Q. You know the value of T1, you know the value of T2, you know the value of L, you know the value of K, and you know the value of A. These values you have to substitute. So, once again I will write this formula. Q is equal to, this is T1 minus T2 by L by K A. Q is equal to T1 value. T1 value is equal to how much it is given? 150. T2 value is equal to how much it is given? 45 by L value. L value is equal to how much it is given here? 0.15 by K value is already given in your question. How much K value is there? 9.35. 9.35 into what is the next value? 9.35 into what is the area? Area is equal to how much it is given? 4.5. 4.5, okay na? Q is equal to, now this one with the help of calculate, try to solve this one, you will get the answer. Here you know the value of T1, you know the value of T2, you know the value of L, you know the value of K, and everything is there. So, with the help of calculate, try to solve this one, you will get the value. The value somewhat like this, 29452.5, 29452.5 watts, somewhat like this, 294,525.34. You will 29452.5, 52.5 like this. With the help of calculation, you will solve this one. Like this value you will get. You got the value of Q. Here as you can see, you got the value of Q. Q is equal to T1 minus T2 by L by K is there. So, Q is equal to T1 minus T2 by L by K. You know the value of T1, you know the value of T2, you know the value of L, you know the value of K, and you know the value of area. If you substitute, you will get the value of Q. Like this, you will get the value. Already T1, T2 is given in your question, length is also given in your question, and thermal conductivity is also given, and area is also given. If you substitute, you will get the value of Q. After getting the value of Q, is asking, say this, see, this is your first bit, this one is your first bit. Next, second bit, he is asking to find out the thermal conductivity. He is asking to find out the temperature gradient, that is dt by dx. He is asking to find out the value of dt by dx. This one is known as temperature gradient. This one is known as temperature gradient, dt by dx. What you have to find out next one, dt by dx. With the help of that, again you have to find out the dt by dx. For finding, next what you have to do, you have to find out dt by dx. For finding dt by dx, what you have to do, see here, till here is as it is only. You got this value 29452.5 kilowatt. After that, see, I will tell you how to find out the dt by dx. How to find out the dt by dx. How to find out the dt by dx. See, from here onwards only I am changing here, because I want dt by dx. What I want? Dt by dx. So, here what you have to do mean, again you have to write down this equation. What is the equation? Q is directly proportional to A dt by dx. This term you have to find out. This term you have to find out. For finding that term, what you have to do, this one you have to send this side, and this one also you have to send this side. These two terms you have to send this side. For finding this one, see here what I am doing, Q divided by minus K A, this one can be write as a dt by dx. Negative sign you will not consider here, because temperature gradient will be there. So, what you have to write, dt by dx is equal to q by Ka. Dt by dx is equal to q by Ka. This, after that, see here, dt by dx is equal to q value, you know very well. Just now you got, how much you got the q value? 295. As you can check that q value is already you got. How much you got q value? 29452.25. 294, I will write here, 29452.5. This is the q value. Q value means 29452.5 kilowatt. This is the q value. So, see here, q by Ka, write down as it is. Next one, dt by dx is equal to, q value you know, 29452.5. K value you know very well. K value is given in your question, in as you can see in your given data. How much it is? 9.35 into area value is also know. How much it is? 4.5. So, you you will get here dt by dx is equal to 700. If you solve this one, how much you will get the value? 700. You have to remember the unit, centimeter per meter, centimeter per meter, centimeter per meter. This is the unit, see, centimeter. Why centimeter? Here temperature is there. What is there here? Temperature is there. Temperature is there. That is why dt is there, centimeter. And dx means thickness will be there. Dx is stand for the thickness. For thickness, how much unit is there? Meter. So, centimeter per meter, centimeter per meter. Like this, you got the second bit also. This is your second bit, dt by dx. This one is your second bit. Okay, na? Like this, you have to find out 700 centimeter per meter is there. With the help of q is equal to minus Ka dt by dx, you will find out this problem. You will find out this problem with the help of this one. Okay. And the next problem is similar to that one only, but the given data is different. So, what we have to do, first we will go for the problem question. The following data are related to the oven. Here what is given? Oven is given. What is given here? Oven is given. Okay, na? Thickness of the side of the wall of a oven. Thickness of the side of the wall of a oven. Thickness is given. You have to remember, first you try to draw the O1. Okay, no need to draw the totally O1, just you have to draw the line diagram of a O1. This one is your O1. Okay, no, this one is your O1 is there. Okay, no, this one is your O1 is there. As you can see here, this one you can consider as a O1. Let it be this line diagram only. Okay, no, this one you can consider as a O1. After that, what you have to do? After that, what you have to do? Here, thickness is given. How much thickness is given? As you can see, the thickness is equal to 82.5 mm is given. So here, from here to here, thickness is given. How much thickness is given? 82.5 mm is given. How much thickness is given? 82.5 mm is given. This thickness you have to convert. This thickness you have to convert. So here I will write 82.5 mm divided with 1000. 82.5 mm divided with 1000. The answer you will get in meter. I will convert later. First I will extract the given question data. How much data is there in that? After that, thermal conductivity of a wall insulated. Thermal conductivity is given. Thermal conductivity is designated with the letter K. K is given. K is equal to how much? K is equal to how much? 0.044 watt per centigrade, watt per meter centigrade. 0.044 watt per meter centigrade is given. Thermal conductivity is designated with the letter K. Thermal conductivity is designated with the letter K. After that, temperature on the inside of the wall. Temperature of the inside of the wall. So T1 is given. T1 is equal to how much you have to take? 175 degree centigrade. How much it is given? 175 degree centigrade. And energy dissipated by the electrical torch. Dissipated means it will move. Move means heat will be there. What will be there? Dissipated. Energy dissipated means energy is leaving. Energy is leaving means Q value. That is your Q value. Q value is equal to how much? 40.5 watt. Otherwise, by seeing unit also you can identify what is the unit here, what is there. By seeing unit also you can identify, that is 40.5 watt. 40.5 watt is there. After that, he is here, energy dissipated by the electrical coil within a oven 40.5 watt, and determine the area. What he is asking to find out the area. He is asking to find out the how much area is there. How much area is there. Determine the area of the wall surface perpendicular to the heat flow so that the temperature on the other side of the wall does not exist. Means T2 value is also given. T2 value is equal to how much it is given? 75 degrees centigrade. K value is given. T1 value is given, Q is given, area is given, as well as T2 is given. He is asking to find out the, he is asking to find out what he is asking to find out the area he is asking to find out. For finding area, what you have to do? You have to write down that equation, that is Q is directly proportional. Q is directly proportional to A dt by, what you have to write here? Dx. Q is directly proportional to A dt by dx. After that, Q is equal to here minus Ka. This one you can write as dt by dx. Q is equal to minus Ka dt by dx. After that, what you have to do? Q is equal to Ka. Here you can write T2 minus, let it be as it, T2 minus T1 by, this can be write as the dx. This can be write as the dx. Then Q is equal to Ka. Here you can write T1 minus T2 by, here you can write dx, write down as it is. Dx write down as it is. After that, you have to go for cross multiplication. After that, you have to go for cross multiplication. So here you will get like this. If you go for Q into dx is equal to, Q into dx is equal to Ka. Here you can write T1 minus T2. Q into dx is equal to Ka T1 minus T2. Then what you have to do? Q dx, let it be there only. This K you send this side, and this is T1 minus this is T2 is equal to how much it is? Area. How much it is? Area. Then area is equal to, you know the value of Q. Q is how much it is given? Let it be first write this one, Q into dx by K into T1 minus T2. Whatever the method you want to apply, apply. Whatever the simplification you want to apply, apply. Separate the area, separate the area. Go for cross multiplication, separate the area. Area is your subject. So, you have to separate the area. In your question, he is asking to find out the determine the area of the wall. He is asking to find out the determine the area of the wall. So, with the help of that, go for the cross multiplication and separate the area. No need to follow this method only. You can go for any simplification, but separate the area. So, after separating area, you have to substitute the value. Area is equal to Q value already given. How much it is? 40.5. As you can see here, 40.5 is there into dx value is also given. Dx value thickness value is equal to how much? 80. With the help of calci, try to solve that dx value. How much you are getting? 0.0 how much it is? 0.0825 meter. How much you are getting dx value? 0.0825 meter. So, here 0.0825 meter. After that divided by k value you have to substitute. Where the k value is given? K value how much? 0.044. So, here you have to write 0.044. Then T1 value, T1 how much? T1 value is there? 175. Then T2 value is equal to how much? 75. T2 value is equal to how much? 75. As you can see here, after separating A with the general equation, this one is known as the Fourier law of heat conduction equation. This one is known as the Fourier law of heat conduction equation. In Fourier law of heat conduction equation, go for this till here simplification. Till here you have to go for the simplification. After that, what you have to do? What you have to find out? That one you have to make as a subject. Go for the cross multiply. Now, what you have to find out in this problem? I have to find out the area. Remaining things are given in every problem. In previous section, as you can see that in every problem he is asking to find out the Q, but in this problem Q value is given. Q how much it is given? 40.5 watt is given. By seeing the unit also you can identify the Q value is 40.5 watt. If you are not unable to identify the what is Q, then by seeing the unit also you can identify Q value is equal to 40.5 watt is given. So, here you have to find out the value. Which one you have to find out? You have to find out the value of area. For finding the area, go for cross multiplication, separate the A, and remaining Q value is given how much it is? 40.5, and dx value is given how much it is? 0.0825, and k value is given how much it is? 0.044. T1 value is given 175, T2 value is given this one. What you have to do? If you solve with the help of calci, you will get something like this. With the help of A is equal to 0.759. The unit is meter square. The unit is meter square. With the help of calci, if you solve this one, you got the value of A 0.759 meter square. 0.759 meter square. This is the value of A. This is the value of A. Like this, you have to find out. This is A is equal to 0.759 meter square. This is the value of A. Like this, you have to find out. Once again, I will read the question. In this question, nothing is given. Simple question is given for 5 marks or sometime maybe in 10 marks. The following data related to the oven. Oven is given. First, you have to draw the diagram of a oven. It is not necessary. It should be as the exact only. As per your convenient, you can draw the line diagram. After that, thickness of the side of the wall. Thickness is equal to how much is given? 82.5 mm. It is given in mm. It is designated with L, dx, x and L. I told you 82.5 mm divided with 1000. 82.5 mm divided with 1000. So, 0.0825, here you got the meter. You have to convert into meter. After that, thermal conductivity of the insulator is given. Thermal conductivity is designated with the letter K. So, K value is given. Then after that, temperature of the inside of the wall, T1 value is given. Then energy dissipated by the electrical coil, Q value is given. Then area you have to find out. Then T2 is equal to how much? 75 degree centigrade. Now, what you have to do? Q is directly proportional to A dt by dA. If you remove this proportional sign, minus Ka will come, then minus if you multiply inside, this will become plus and this will become negative. After that, what you have to find out, you have to check, you have to find out the area. For finding area, go for the cross multiplication and separate the area. After getting area, substitute the value, you got the value of area here. In this problem, he is asking to find out the area, and the next sections we say the more problems based upon this topic. Okay, thank you everyone.